Hey guys, today we're talking about CNH auto guidance systems on their agricultural equipment. First, we're going to start off with the components that these systems are made up of, and these are the transferable components. First, we have the receiver, a nav controller, which can sometimes be transferable, but sometimes not, and the display. We're going to start off with the display. Over to the right you see Fred and then SWCD. Those were the engineering names of these displays. Right below that you see the AFS Pro and then TeleView. The AFS is the Case IH name for the display, and then TeleView is the New Holland name, even though they're the exact same. They have different names. And then the TeleView 4 is the most up-to-date display. The TeleView 4 or the AFS Pro, these displays allow you to first of all see what you're doing and everything, and then you can also set up your navigation, you can calibrate the navigation and other things. You can do performance tuning through these displays, basic troubleshooting for the navigation. And since most of these navigations are built into the tractors now, you can also do other functions like control your remotes. You can keep them locked out, you can lock them in, you can control their flow rates, you can put a timer on your remotes, and there's so many other things you can go and do through this display. You can get fuel efficiency, all of that. And on the bottom of the screen you'll see you need the correct software must be loaded to perform auto guidance tasks. And you need to make sure all of your components are up to date with the same software so they will all communicate together effectively. Next we move to the receiver. The receiver is the antenna of the system. And then the antenna also has different packages in it. You can get WAAS, which is the standard, or you can also upgrade to Omnistar or RTK, which RTK is the best. These receivers, you're going to have to tell the tractor where you have mounted these, because where you mount them on different locations, it will be different for it. So say it thinks it's on the front, but you mount it on the back, you're going to be that 10 feet off or whatever. And that you're just going to throw your whole auto guidance off. And again, on the bottom of the screen, you need to have the correct software. The nav controller. So the nav controller, it pretty much is the translator for the system. It also can adjust the GPS positioning for the terrain that it's in. As you see, there's 3 axes that control pitch, roll, and yaw. It also reads data from vehicle sensors, and it combines all the information and it calculates the steering commands. Again, you need to have your correct software on it, and these are going to have to be calibrated for where they're mounted in the tractor. It will change the measuring components in there if it's mounted differently, so you always have to calibrate it. Non-transferable components, you got your wheel angle sensor, manual override, operator presence, auto guide, enable / lockout switch, also could be called a road switch, auto guidance valve, and remote engage switch. First off, we have our wheel angle sensor. This tells the computer how far your wheels are turning. There's different kinds of sensors. You got your rotary potentiometer, linear potentiometer, or the Trimble AutoSense, and that just gives a relative value, whereas the potentiometers tell exactly how far the wheels are turning. Trimble AutoSense just tells that the wheels are turning. That's a little further than what we're gonna go today. So we'll go to the next slide. Manual override sensor. It allows the operator to take control and steer the machine manually. Detects steering wheel movement. This is just a safety switch pretty much. And there's 4 different kinds of sensors that allows this function to happen. Like, you can use 4 different sensors for any application. Operator presence. This is just another safety switch. Make sure the operator's in the seat so the operator can't walk off. If something goes haywire and the tractor just keeps driving straight when it needs to turn, it's not going to run into anything and cause any issues. Your auto guidance lockout switch also could be known as a road switch. You have to always enable this before you want to use the auto guidance. Sometimes if you're going into road mode, you'll have to click the switch in some applications for it to reach maximum road speed, and it will lock out all your implements functions. And then your remote switch is going to be on your multifunction handle. This multifunction handle is out of a combine. The T7 you'll see in my next video is going to be in a, I don't think you'll see it, but it's in a different location. It's in the top left hand side of it. So it should always be on the multifunction handle, and it'll look similar to that. Sometimes it can also be in a foot switch. It's just puts the enabling in a more convenient spot for the operator. The auto guidance valve, it just directs hydraulic oil to the steering cylinders. It's just a valve, and it reacts from the nav's commands. And calibrations. We talked about a little bit of calibrations before. You got to start off with your wheel angle sensor calibration. This will learn the minimum voltage value, highest voltage value, and your center voltage value. Dead zone calibration also could be known as your spool calibration. It allows the tractor to figure out how much voltage that spool needs to get before it starts moving oil and how much oil it's going to be moving. Your roll call, that's the calibration for your nav controller. And then your P gain. The P gain is kind of more of a tune, like performance modification, than an actual calibration. It just allows it to work a little bit more smoothly, and the P gain is not something you always need to do. Wheel angle sensors makes the tractor learn the voltages. Trimble AutoSense does not require a wheel angle sensor calibration. That's because it just tells the tractor that the wheels are turning, not that how far they're turning. Dead zone calibration, could be known as a spool calibration. I already went through and talked about this. It just makes the system more efficient. Roll angle calibration, it corrects for where the nav's located. Proper roll calibration allows the nav controller to determine vehicle centerline. P gain determines how aggressively the vehicle corrects for cross-track error. Calibration is not required, like we talked about. Only perform P gain calibration if performance is not satisfactory, and you always have to do it in working field conditions. It's not going to do you any good when you're in on like the road or on hard packed ground versus when you're going to be, say, in muddy muck. It's going to totally be different. This is more of a tune and not really calibration. And then I'm not going to show the video through here. It doesn't work through here. But if you can go and click the next link and watch the video, that'd be great. Thanks, guys. Have a good day.